So I'm Michael Spivey with 3dprintmakers.com, and I'm here with Brook Drumm, and we're going to talk about 3D printing, makers, all things about making and what developers do, whether they're developing material things or more graphical things. So thanks for joining me, Brook.
Oh, it's great to be here, man. Thank you.
Yeah. So I wanted to start off, before we had talked a little bit about 3D printing, the tools, what makers do. I wanted to talk a little bit about that this time, but before we do, you're also an entrepreneur, started your own businesses, and I was wanting to get your thoughts on going from a maker to a business maker. So
yeah.
So how did you find your audience, or what you wanted to do?
Well, the first business I had was a coffee shop restaurant, and I loved coffee. So I went after what I was passionate about. And then I got into web design, and because I loved art and I loved internet and computers and the web, and I got into IT, same thing. So I've always gravitated towards something that I was really excited about and really interested in. I think some people do themselves a disservice when you see an opportunity in a market, like I think some 3D printing companies did. Well, this, that's kind of cool and it's popular, so I'll do that and I'll make a bunch of money, even though they're not really that passionate about it. And the companies that I always kind of spotted right off the bat was when you get a design of a printer, because I designed my own printer. MakerBot, they designed their own printer and so on and so forth. The ones that you would know, Prusa, he did base his off of a previous version, but it turns out he was good at it, loved it. So when people go after their passion, I think the product ends up far, far better. So I've always just followed my own interest. Now, making money from that is sometimes impossible. I mean, literally impossible. For instance, it'd be very hard to get into the 3D printing space today, at least with a big impact. I was early enough that, I just recorded Bree Pettis yesterday, and me and him were talking about, the early days. He was even earlier than I was. Literally no one was doing it. And since he was the first to do a business, the guy that formed the RepRap movement even invested $75,000 in the company, or $50,000 in the company, because no one had done it yet. And he was like, well, this ought to be done. So anyway, timing is a lot. Timing is really a lot. But so
if timing is important, and there's other people that say that as well, being the first mover advantage or inventing something is different than building a market for it.
True.
What strategies do you use to try and make sure that you're either in the game long enough or can do enough bets that one of them happens to pay off? Because none of us are able to predict the future. Some of us are willing to put in the time and the effort to help make the future, even if we can't predict it. And then maybe 50%, maybe 10% of those will actually turn out to be accepted by other people. What are your thoughts on being able to give it enough tries?
I didn't want to overstate earlier when I said that it's impossible with some things. Like, for instance, let's throw out the ridiculous and just say that I do believe that anything is possible. So I didn't want to, all I'm saying is I think some businesses are way more risky to go into than others. But one that you're passionate about, one that you're good at or improving at, I think is fair. So how I kind of developed, well, first off, I have to be honest, the Kickstarter is how I got started. So I ended up with this load of cash, and I had the money. I didn't have to raise funds. But I'll tell you, going back further, is I decided that I wanted to pursue a business around 3D printer kits. And so the first thing I did was I decided, well, I better become an expert because, and find out if I like it. So I just went all in on 3D printing. I bought a printer, saved up, took a long time, saved up for a MakerBot, And then I taught myself to 3D design. I'd done 2D design before, doing web work and stuff.
And
So
how did you decide what to 3D design? Did people come to you with ideas, or did you already have ideas in your head?
well, I was when I built the printer, the cupcake MakerBot, there were things on it that you know, it was the first one really out in the hands of people, and it hadn't been vetted much at all. And so the real popular thing to do, just out of necessity, to keep the machine running and printing better, was to print parts for the printer. So, you know, I was into, you know, like I was doing homebrew beer at home, and I was so I'd do like little bottle openers just to give away to friends, or I'd do keychains just to try to do my kids' names, or I was really just picking things that I could give away and they wouldn't throw it away immediately, you know, because the resolution, you know, early on, it didn't look awesome. It was novel. So I just wanted some novelty just so I could like keep them thinking about it. So I chose different things. I was into cycling. Again, you see, I always go after the things I'm interested in, passions. I was into RC cars. I was into bicycling or cycling. So I do little doodads and add-ons and keep it kind of around something that I was interested in. So anyway, the cash that I started with gave me an unfair advantage, but I decided to just put the time equity in before the Kickstarter. And so I really did, for a solid 11 months. If I didn't design every day, I mean, I'd be shocked. Every day. And some days, many, many hours. In some weeks, many, many hours. I went really, really deep into it.
And so, did you do full, so you'd design these things, you'd come up with ideas, you'd sit down, you'd design them, you'd print them out, you'd give them to people, the keychains or other things, and you'd test them out.
Well, that was early on. I kind of formed a meetup group like a month after I got my printer.
Okay.
And I said, okay, I'm going to get people together that are excited about 3D printing. And I think even since the MakerBot was the only one out, I didn't even call it 3D printing. I called it the MakerBot Builders Group.
Oh.
And then I got there and they were like, well, I'm into RepRap. And so I was like, okay, we'll change the name, RepRap and MakerBot Builders Group. And so we were all building printers. So all my little trinkets and stuff just ended up being 3D printer parts. And I did do a few studies in like, okay, there was this, what is it called? The GATA prize or GATA prize, where they said somebody offered up a bunch of money to, if you are able to design a 3D printer that prints itself up to like 90% or something, there was like $100,000 prize or something. So I thought, I'm going to win that prize. So I was doing studies in like how to make the structure 3D printable and all this. And that was kind of a sideline. So I was doing dovetail joints and like weird joints and stuff to learn. I mean, it's the first time the world was at home making things out of 3D printed parts. And like all of that was, you know, not for the taking because it wasn't a profit thing. I wanted to sell printers. So anyway, I did lots and lots of design on printers. And the design eventually became the original PrinterBot out of a necessity to save money and be small enough to fit on the desk of a student. So that ended up being my niche. And so that kind of brings me in when you start a business, you have to have a niche. You have to have a target market. You know, if somebody says, well, who are you making 3D printers for, Brooke? If somebody asked me, oh, everybody, the whole world, whether it's teachers or scientists or kids, it doesn't work like that. It's just like cars. You know, there's so many different models of cars because each one is very carefully targeted at a market. So I really believe, like my coffee shop, when I opened that, it was for college kids because it was down the street from a college. I was in college, and it was an internet cafe. So again, I like tech.
So it's always been with technology of some sort. Right?
Yep. And we had music because I love music and I'm a musician. So there was those three things. And if you liked, my partner was like an English major, and he went into, you know, teaching he's a professor. So he had all these old books on the tables. And so it was just be yourself, go after what you love, but make sure that it's a niche that stands out and you know, with software, I think the same thing. You know, like it was funny. I was talking to the guy that edits my podcasts, and he uses Logic, which is an expensive program. It's a very nice program. It's a kind of a Mac thing, right? Mm-hmm. And so already we're getting off into the niche category. You got to spend money.
Started up here, and now you move down to this one particular guy uses this one particular software on this type of computer, but it works for you.
Yeah, but I was a open source guy because I was poor, and so I use Audacity, and that can be on Linux or whatever. But I tell you, I think some software that's multi-platform does suffer from an identity crisis, because you see nowadays where software on a Mac or on an iPhone looks very different by nature sometimes because of the rules imposed. Yep. But sometimes it's just because they love aesthetics, and Mac people, snobs or whatever you want to say, they like aesthetics and they like simplicity, and he was always saying, if I could only remove the button on the phone, and finally he did. So anyway,
I think that's probably summed up in these terms like mobile native or cloud native, is people have found that while it might reside in an area, it's not really authentic to that environment. And so then in doing this type of stuff, then there's also the authenticity, or does it fit in with the culture of who's using it?
Oh yeah, true. So those differentiators, I think, are just important. They're important.
So how do I'd like to get back to the Kickstarter thing.
Sure.
And how that was successful or not successful, and how you found your audience there, and how do you you're a maker, how did you give yourself an identity that other people resonated with?
So the Kickstarter struck me like a ton of bricks, and I realized like you're pushed into the limelight very quickly. And especially me, because it was the intersection of, crowdfunding was new, so Kickstarter was new, 3D printing was new, and just the whole maker culture was like booming in 2011. And so I was at the intersection of all three of those things, and became a poster boy. And I was the highest tech raise at the time. There's different categories like art and music with Kickstarter, and I was the #1 tech raise, and I was just like, what's going on?
So this in 2012, late 2012?
2011. I think it was 2011.
And so the highest amount raised on Kickstarter for a tech project in 2011?
Soon to be trounced by, other things like another 3D printer or a watch. The watch.
Was that the Pebble watch?
Pebble. Yeah. And then eventually, what was that cooler that was a blender and a radio? That went to like 11 million. Makes no sense. I don't even think they delivered, or anyway. But so the audience was there because of Kickstarter. Now, the people that bought from me, early on in Kickstarter, they had different terms of like rules, and you actually did not have to have a working prototype, believe it or not. Yeah. I chose to, because I was scared that I wouldn't be able to do it if I didn't prove it to myself. Mm-hmm. So I had a working prototype. It got better.
And what was the level of prototype? Just some stuff strung together that actually did print, or did you have some, other than the printer itself, did you have some feasibility that you'd actually be able to manufacture it at some facility?
I was going to 3D, the original pitch was I'm going to 3D print 50 printers and use stuff from a hardware store. So I went down to the Lowe's and got some 5/16 rod and nuts. That was my Acme rods. And I tried drill rod. I went to all the hobby stores. I mean, I wanted it to be locally sourced. I didn't want to have to go buy it somewhere else. Now I found out that, like eBay was where you got your steppers or whatever. That changed when it was not 50 printers, but it was 1,200 printers. So that changed the game. But originally it was actually a finished model, because I was doing it for the meetup group first. We wanted to print. And so that was all my design time, was to make the little printer bot original better and smaller and less materials and less cost. So it did work. and the people in my meetup group that grew to about 60 people. When you stand up and say, like, that meetup group is, I think it's a really good idea. And even if you're starting a business, I think these, meetup groups about, whatever you're into, whatever your business is, if you're a carpenter, finding other carpenters, that really creates having a community of people that are like you with businesses like you. Restaurant owners, they all navigate to each other and share resources. I think that's very, very valuable. So I wondered if some of the people in my meetup group would also start businesses or also do Kickstarters. And I think some of them tried. In fact, I know some of them did because they saw me do it, but I encouraged them. But we just chose different niches, But anyway, so the printer kind of had its own, it was low cost. So that of the people at Kickstarter that did purchase, some of those people ended up being the ones that were, whether they were just like me or there was people that kind of came to one side that were serious about 3D printing. Some were just checking it out. They were buying a new thing. And I think some of them never got built.
This is because on your Kickstarter project, you actually shipped it as a kit to put together, or did you ship it as a final built product that they just plug in and use?
There's a much higher cost for built. So those like a half a dozen or something were built. Okay. The rest were much cheaper as kits. And so essentially everyone got kits. And once I saw that, I was having to make hundreds of these, I was like, it's going to take so long to print. So my buddy at the meetup group said, I know how we can save you some time. Let's laser cut them like MakerBot does. And I was like, well, I don't have a laser cutter. And he says, well, I do. So how about we do the prototype on mine, and then you're going to have plenty of money to buy laser cutters, dude. So let's get the prototype done before the end of the Kickstarter. So we actually got it done very quickly, and it looked similar. And it was like the old Plus wood printers that I did. We called it the LC, same size, 6x6x6. Then we had a Plus version that I offered also. And so I said, hey, you can change your bid on Kickstarter. Change your purchase if you don't want a printed parts and you like the look of this laser cut. And that went mad. Like that, people loved that. They wanted a laser cut kit, not a 3D printed kit. Some of them wanted the 3D printed kit, but it was probably 2/3 of laser cut parts, which really helped me out because the manufacturing was way easier for laser cutter. Still time consuming, and there were still printed parts on those models, but far fewer. So they all had wiring, they all had electronics, they all had power supply.
And what was the type of thing? What was the micron resolution for that type of printer? Was it around the 100 micron, or was it more like 50 micron?
Back then, we all were doing 0.5 tips. Like that was all you could get. It was 0.5. Okay. Nobody even thought of doing another tip. So the width would be 0.5. And I thought that you should just print in like a 0.3 layer height. So that's what I printed in. So my parts were printed in 0.3 layer height. Now you could do 0.2 and it looked a lot better. And then somebody said, well, why don't you do 0.1? And I was like, well, that's silly. Why would I do that? And he goes, no, you ought to check it out. It's really cool for really intricate things. And so I said, okay, I'll try it. And it did that. And then somebody said, well, look at what I did in 0.05. And I'm like,
and it looks really good, but the amount of time it takes is a whole lot, right?
Yeah, 1 hour print became an 8 or 12 hour print. So I was like, I'm not doing that fine printing, man. I got to get stuff shipped. So it was always possible to do a higher resolution, but we didn't know enough at the time to know the things that contributed to that. By the way, this was all ABS too.
Okay. So that's basically like Lego type plastic, right?
Yes. And ABS was most popular first because PLA, turns out, is actually harder to extrude. So there were far fewer. There's only one manufacturer of PLA, the pellets, in the US, and like I think 2 in the world or something crazy. It was just weird. And they used it for a completely different thing. It was a different chemical, compound anyway. So ABS was easy. Everybody was using ABS, and we had pellets available. So that's what people extruded first.
Okay. And thinking about, so that's 2011, that's ramping up, and you talked earlier about timing is important. 2021, maybe in the 90s, there's the Trio mobile phone, the BlackBerry, And then it
Yeah.
took 2007 and Steve Jobs, to really popularize, go from, 10 million mobile phones to billions of mobile phones, or hundreds of millions of mobile phones. So thinking of timing, the 3D printer itself wasn't invented in 2011 or 10. It was invented, I think, back in like 1975 or some really long time ago.
35, 38 years ago, yeah.
And so thinking about the future, I know there's people like Ray Kurzweil, who's currently at Google, and some other technologists that predict when the resolution of 3D printers advances to the nanometer, which is sub-micron, that clothing will be practical to print. And they actually see the killer app, if you will, of nano creation, or these nano factories being able to produce clothing.
Wow.
So when we think of 2021 or 2025, is there anything, you're pretty close to the technology, is there anything in your crystal ball or timing that makes you think that that was a first wave and there will be a second wave? Or do you think that the physical limits were hit and it was already pushed as far as it could be pushed?
I definitely think while I was in business in the last 8 years, there was, well, it all started, by the way, the desktop, because of the patents expiring.
Okay.
So the timing was, you can do this and not get sued. You can do this. And, the Adrian Boyer at University in Bath, he said, well, I better get it out there in the open source with software and like prove that it works, so they can't, trap us again with patents, So which sometimes happens. They just kind of change little things and then they repatent it and you're blocked again. So once it got out there and the cat was out of the bag, you can't unring the bell. So people just started going nuts with it. Now, there were a couple of lawsuits that followed to try to, with the heated bed and enclosed build chambers. They didn't hold up in court. And so finally we were free to develop. Now, in that time, though, I'll tell you what got a lot better. We got better at manufacturing these printers far more cheaply, far more rigidly. We learned a lot because these companies weren't going to help us. Stratasys and 3D Systems, they knew everything that we know now a long time ago, but they didn't want to. The most
impressive one that I've seen, at least on YouTube, was a TED Talk where I believe it was Carbon, which might have been either purchased by Ford or used by Ford.
Yeah.
Produced some really amazing technology with how fast they were able to do reliable prints. I haven't seen any of that in person, but
I've seen it in person, and I'll tell you, it's amazing. But here's the sad part of that. They used a common, it wasn't a really breakthrough in science. They just realized, oh, you could do this. And they use a film that lets oxygen through the bottom of the resin, and they patented it. So
okay,
now
so it's locked up again, and
it
probably won't see innovation in that space.
Right. So that was really sad. But, when you get a lot of really smart people motivated, you find new innovations. So I don't think that's the end for the fast resin printers. In fact, a friend of mine, Bill William Steele, he invented, let me put it this way. There were some prior art out there, which just means people showed this stuff publicly online, of the belt printers. I had one called the printer belt.
What is a belt printer?
So the belt printer replaces, let me go back to the MakerBot. When I got my cupcake, you had this one little clever idea that you could take a conveyor belt, print on the conveyor belt, and then advance the conveyor belt, and it would kind of pop off the end and you'd print another one. So it was XYZ axis printing on a conveyor belt, so you'd have extra electronics to kick that off. Well, it didn't work very well. Whatever the tape or the coating, we didn't know about. How about glue stick? There's a lot of things that we didn't know. But we've proven that actually does work now and can be done. The problem was it was a patent. So you couldn't do XYZ plus a conveyor belt. And so everybody stayed away from it. Well, William Steele saw this one guy and then kind of copied it. And he says, oh, the patent reads, and he got his lawyers involved. The patent reads XYZ plus belt. How about we do XY belt plus and Z, XZ plus a Y belt? And so he says, yeah, you're in the clear. So that's what we did. So then I saw it and I said, I got to build one of these. Will you help me? And then black belt came out about the same time or a little bit earlier. Bill preceded the black belt. They were a company that came out with a belt printer. So the idea is technically you can name the axis, but one of the axes can be infinite. So you could do, like I did a 6-foot long sword was the first thing I did.
Oh.
And it
was one continuous sword?
Yeah. And it was on a little desktop printer. It just spit out one axis.
Did it have a 6-foot long conveyor belt, or it had a foot-long conveyor belt, and eventually the sword would just kind of slide off onto the desk that's resting underneath of it?
Yeah, I put a 2x4 up on bricks, and it just kind of slid off onto the 2x4. And so the belt printer was neat for long prints, but it's also neat to do multiple parts. So you could do 100 of the same part, or 10 of 10 parts, and just have the whole. It's kind of like a little factory. So that was an innovation that's really yet untapped. Now Black Belt patented their belt material. I think they did carbon fiber, but there's a lot of fibers out there. I'm talking to a belt company right now to try to find another good belt material, just so people can do it again. So innovation's always going to happen. People are motivated, but sometimes there are those points at which there's an aha moment, and this is what happened with the belt printers, when we all realized, oh, we're not going to get sued if we start toying around with belts. So, and I even asked Bree, who owned the patent for a while. I don't know if it went over to Stratasys or not. I was like, you going to sue me if I do that? He's like, no, I'm not going to sue you. But anyway, so the other innovations I look for are, well, of course, materials has come a long way.
Yeah.
Have
you heard of Eric Drexler or watched any of his videos?
No, or maybe I have, but it doesn't ring a bell. What does he do?
So Eric Drexler is extremely interesting. I believe he coined the term nanotechnology back in maybe the late 80s or early 90s, and I think he's at either Cambridge or Oxford now.
Okay.
But he talks about atomically precise nanofactories or atomically precise manufacturing. And supposedly MIT and different groups are working on this concept of atomically precise manufacturing and showing the science of it and how it's theoretically possible, and some practical thing, or not practical, but implementations of it might be how IBM, wrote its name and
right. I have read about this.
Something like that. But if you ever get the chance, look up Eric Drexler. And he talks about some really interesting stuff, but he also talks about this mix between science and engineering, and how there's a lot of science, but there's a need for more engineers to do the real implementation, to go in their garage, put the 2x4s on, and actually do these long sword prints to work out, working systems.
Eric Drexler.
Yeah.
Okay, I'm gonna check it out. Yeah, it's funny. I've come in contact with a lot of scientists that were, way smarter than me in that area, and it is funny their approach sometimes. When this one talk was saying, it was a big news item. By the way, the media, you got to be careful because there was such a hype around 3D printing. We were just like, oh, everything they say is true. Well, not everything CEOs say is true. Not everything, news say is true.
The hype can be bigger. That goes to the S curve, which technology people well know, but there's a hype cycle.
Totally, absolutely. But anyway, I heard the guy that said we're the first ones to prove that you can print blood vessels, and we're going to print organs. I listened to the whole talk, and the whole room's like, oh, this is amazing. Isn't it great? We're alive in this time where we're growing organs and everything. So I went up and I said, kind of interesting. How long did that live? Or could you say that it was alive? And he was like, well, live is a term that, is a little bit. I was like, seriously, how long until the cells just die? And they're using, like collagen or whatever it was. And he was like, I mean, like a fraction of a second.
So he's really like more honest headline would be like 3D printing dead blood vessels.
Yeah, exactly. Yeah. So I was like, dude, this is never going to happen. He's like, maybe it will. And I'm like, I think this is just not helpful. You know, it's
Yeah,
like,
I think some of that's just a fundamental non-grasp. Obviously, a complex system can't necessarily come together, piecemeal, just adding blocks to the end. It's a dynamic system.
Anyway, we won't get into, how that breaks down. But as far as 3D printing, I do think that the materials have gotten so much better. Now you see like nylon X or like nylon filament with either fiber or carbon fiber, glass fibers or carbon fibers. Those are very resilient, very stiff. For an FDM printer, that's very, very good. I talked to Max from Formlabs and I asked him, what's the strongest material you can have? He said, he was very honest. He said, listen, you can't do resin and really, really strong. It's always going to be brittle. It's resin. Mm-hmm. So that's why he's making a, fused powder machine, an what is it? SLS? No, SLA.
Is this basically where there's some type SLS. Of powder, maybe it's metallic, and then it's basically like microwaves or some type of ray from 3 different directions, and where it triangulates, then it heats it up enough?
Well, he's actually doing, it's the same process, by the way, but it's lasers typically. And some have done plasma, like there's a bunch of different ones, but this is non-metal, so it's plastic, but it's like nylon. But when it fuses through a laser, it spreads the powder over the top of the bed, very, very thin layers, and then it traces over it with the laser. And where the laser hits, it fuses together. Well, the fuse on that is really, really 2 advantages. One is it's very strong. Where you can have delamination in 3D printing. It does not delaminate. It's a solid block of plastic.
So delaminating or laminating is basically thinking of like just adding layers that can be brittle or taken off or not.
In 3D printing, delamination, it prints 1 layer at a time. So it would be like you tried to glue 2 pieces of paper together, but you could still rip them apart. Okay. The really, really good bonding and good lamination is you can't possibly tear those 2 papers apart. They'll just destroy each other. Mm-hmm. So with this powder and laser process, it is fused together. There's no layers. It's just fused. So it's all one solid part. The other thing that's nice is you have an inherent support structure, the unused powder that doesn't get burned with the laser or, melted with the laser, is there as support. So you can do extremely complex and even, lasers, very small column of light. So you've got high resolution, you've got built-in support, and you've got very strong parts. So there are some advantages. Now his whole system, though, you have to deal with the powder. So you need like another machine to clean the powder out. And like the whole system is like 10 or 20,000 or something like that. It's far cheaper than it ever was. But whenever it comes out, we'll probably
do you see an exponential decrease in prices continuing and an exponential increase in the technology for the same price performance? Or do you see that paused for the past so many years?
Well, I don't know that you could say this across the board, but don't you think that price always comes after, or lower price always comes after demand?
Yeah.
So like, yeah, if we made 1 million rockets to go to the moon, we might be able to afford it. But not everybody wants to go. It's like there's no incentive. It's too expensive or whatever. So I think that the 3D printers, you might see $100 3D printers that are actually good. Right now, the $100 3D printers are toys. Yeah. The $200 ones are toys, and they're not meant for a long life. They're not meant for business. They're toys.
Or I guess I was more interested in these $10,000 systems coming down to
they'll come down
5,000 or 1,000, or their capabilities coming down from $100,000 to $10,000 machines.
Yeah, there's still a rapid increase in just the simplicity of resin printing right now is really being helped by people using screens instead of lasers, so or instead of projectors, so they're using screens. So like it doesn't work with an iPhone as well as that one company would like you to believe. But if you dedicate it and build it from scratch as a screen that lets light through, then you can do pretty amazing stuff with hitting the whole layer all at once, exposing the whole layer of resin all at once, and then moving up. That's how the Carbon 3D works. So it's very, very fast, whether it's a projector or a screen, I don't remember, but there's big improvements still coming, I think, on the resin. And I've even talked to people that were inside large companies. I don't want to say which companies, but they're in the 3D printing department in very large companies. And you would recognize the name of the companies. And they said, Brook, what we have that I cannot talk about is so far beyond what we've been doing here in this space that it's actually shocking. It's unbelievable what the capability of these machines are. But here's the problem. They only make them for themselves. There are no patents because they will never tell anybody how they did it. They're the sole benefactor. And so there are no patents because we don't want to sell it. We don't want anybody to know about it. And we make it because we manufacture things. We need to manufacture a lot of them very quickly. So that doesn't have a lot of appeal to me, even if I did know the secrets. I make just a few things in my house here. So the need isn't there. So we're probably not going to see trickle down on all technology because we won't know about some of it, and it's not built for us to use, really. But, I wish everything was open source. We could at least see it, because I wonder what would happen if we could know those secrets inside those doors of those big companies,
Yeah.
Would the world be a better place?
Maybe one day through some inadvertent, company going bankrupt and the technology coming out or something like that. Who knows what'll happen?
Well, when you don't patent something, somebody else can invent it, and you lost out, buddy. You know what I mean? But these are very, very complicated machines. But I think there's a bright future for 3D printing. I very much do. But you're not going to get much help from profitable private companies. That's why it's fun to play in this open source area. Even partially open is okay with me, because just, it's been so fun seeing what other people design and riffing off that. I still think there's a lot of work to be done that's going to be good, and that we will see costs come down. We will see new ways to 3D print, new materials.
Well, thanks for the thoughts and the time, Brook. And
you bet.
Happy Thanksgiving to you and your family.
To you as well. Happy Thanksgiving.